Alright, this is Chapter 8, Section 2, and 8.3, Properties of Parallelograms. So, parallelogram sort of is the basis of all the definitions of a quadrilateral. We know that a quadrilateral is a polygon with 4 sides, and then we have a parallelogram. And I'm going to use this symbol to call it a parallelogram. So a parallelogram is a quadrilateral where both pairs of opposite sides are parallel. Okay. Quadrilateral with both pairs of opposite sides that are parallel. So if we have this particular parallelogram, PQRS, then I know I have a parallelogram because top and bottom are parallel, left and right are parallel. Okay, and that leads us to our first theorem of the day, Theorem 8.3. And Theorem 8.3 says that if it's a parallelogram, so if a quadrilateral is a parallelogram, then opposite sides are congruent. Right. Theorem 8.4 says that if it's a parallelogram, if a quadrilateral is a parallelogram, then opposite angles are congruent. Right? If Theorem 8.3, if a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, then opposite angles are congruent. So if we have that same parallelogram, PQRS, Theorem 8.3 says that QR is congruent to PS and QP is congruent to RQ. So PQ is congruent to RS and QR is congruent to PS. That's A3. A4 says that angle P is congruent to angle 4, and angle Q is congruent to angle S. So a lot of the math in these equations are pretty straightforward. The proofs in all of these are pretty straightforward too. Uh, Here it is the proof for A3, and really it works for also the proof for A4. You just really change the ending. So if I was to do the proof, we have a parallelogram PQRS. We're told it's a parallelogram, so if we know it's a parallelogram, then opposite sides are parallel. We draw some diagonal. Since we know that these guys are parallel, then I can say that this guy is parallel to that guy, and I can say, or congruent angle, and this angle is congruent to that angle. And then I have enough to say that these guys are congruent because of side angle, side angle, and then corresponding parts are congruent. And so the first step is my givens. It's a parallelogram. You can write the little parallelogram symbol for saying parallelogram in these proofs. Next step, we say, okay, we can draw some arbitrary line, QS. And we can say that because we can say that there are any 2 points, there's a line. So for the reasoning, you don't necessarily have to say that. You can just say draw a line. I'm okay with that. You don't have to go through any 2 points, there's a given line. It's spotted. That's fine. For number 3, since it's a parallelogram, then I know that opposite sides are parallel, so I can say that PQ is parallel to RS, and I can say that QR is parallel to PS, and that's a definition of parallelogram. And then for number 4, I can say that angle PQS is congruent to angle RSQ. And I can say that angle RQS is congruent to PSQ. And the reason why is that this is a transversal cutting across 2 parallel lines. So I could say definition alternate to your angles. space. I can say that QS is congruent to itself. Reflexive property. Then I can say the two triangles are congruent. Triangle QSP, PQS is congruent to RSQ. Because of angle side angle. And then I can say two things. So 7 can be broken up. So for 8.3, I can say I'll just say this. Let's see. I can say that PQ is congruent to RS, and QR is congruent to PS. And that's because of corresponding parts of congruent triangles are congruent, CBCTC. So that's it, 7-step proof. Pretty straightforward. You can also use these whole guidelines to say that opposite angles are congruent. Angle P is congruent to angle R. Corresponding parts, congruent parts of corresponding triangles are congruent. And that would work as well. Alright, so going back to alternate interior angles, if we had a transversal that cut across two parallel lines, we know that consecutive angles are supplementary. So if we have this called angle X and call this angle Y, I know that they're consecutive interior angles, so I know that angle X plus angle Y equals 180 degrees because they're supplementary. Now, with parallelograms, what I really have is two pairs, opposite pairs of parallel lines. So not only do I have one transversal, I have two transversals. And these two transversals connect with each other. So we have another pair of consecutive angles here. We can call that X, and we can call that Y. Because remember, parallelograms, opposite angles are congruent. So if there's an X here, there has to be an X here. There's a Y here, there has to be a Y here. And if these two guys are supplementary, then these two guys are also supplementary, and these two guys are supplementary, and these two guys are supplementary. So I have, if you look at it, this angle X right here is consecutive angles with this Y and consecutive angles with that Y. So every angle in a parallelogram is always has consecutive angles with two angles, two sets of y's, and that's across everyone. So that leads us to theorem 8.5. What theorem 8.5 says is that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So, always. Yeah. Here they got example number 1. They got quadrilateral EFGH. They want to know the measure of FG. So HE is equal to 8. FG is opposite of HE, so they're congruent by theorem 8.3 or 8.2. So GH or GF or FG is equal to 8. Angle G is opposite of angle E, so angle G is equal to 60 degrees. They want to know what X and Y is. So remember, opposite angles are congruent, so J and O are congruent to each other, so then 2x will be equal to 50 degrees. Divide both sides by 2, x equals 25. And then for y, 18 is equal to y plus 3. Subtract b from both sides, y equals 15. So the math behind these guys are pretty straightforward. Alright. And I believe this is the last theorem. Theorem 8.6, and it says that if we have a parallelogram, P, Q, R, and S, and I have some diagonals. The diagonals will bisect each other at their intersection point. So they call it point M. That's where they intersect. So theorem 8.6. If quadrilateral is a parallelogram, then in this case the diagonals bisect each other. So in this case, QM will be congruent to MS, and PM will be congruent to MR. Okay. To give us this parallelogram KJ LM. Got a couple of diagonals at point N. This is 2. This whole thing is 110. This guy's 30. Okay. So, an M. So, if this guy is 2 up here, then this guy is also 2 right here, because it's bisected. Bisect means to cut in half. So NM is equal to 2. Theorem 8.6. KM is just 2 plus 2. I'm just adding the 2 bisected sides, so it's 4. Angle JML. Alright, JML is supplementary with KJM. So if we'll call that and KJM is 110. Subtract 110 from both sides. Angle JML equals 70 degrees. Alright, so we have 2, we have 4, we have 70, and then KML blue. Since I know that this whole angle here is 70 degrees, and I know that this angle here is 30 degrees, then I'm subtract 70 minus 30, and that's going to give me KML, which is 40 degrees. That's going to be 70 minus 30, which equals 40 degrees. The math on these guys is pretty straightforward. Not too crazy. Okay, alright, so that's that section. 8.3 is showing quadrilaterals are parallel. So these theorems are basically the inverse of the ones we just did. So theorem 8.7 is this the theorem of the first theorem on the last section. So that would say if opposite sides are congruent, then the quadrilateral is a parallelogram. Alright, so that's just the inverse of theorem in the previous section. And then theorem 8.8 is also the inverse. And that one says if opposite angles are congruent, and then the quadrilateral is a parallelogram. Okay. So we have a quadrilateral that is, for example number 1, WXYZ W is 42, X is 138. Y is 42. Find Z. So here we have opposite angles that are congruent. So then this guy has to be opposite angle over here. So that could be 138. Or we can just say that a quadrilateral adds up to 360, and we can subtract all of that and say it's also a parallelogram. But they want us to say that opposite angles are congruent. So we say that it's a parallelogram because of theorem 8.7. It leads us to 8.9. So 8.9 is actually different from the others. This is not an inverse of the previous section. This one is a different one. And what this guy says is that if we have a parallelogram A, B, C, and D, and a one side, not opposite pairs or two pairs, one side, one pair, is both congruent and parallel, then we can say that it is a parallelogram. So if opposite sides, I say one pair. If one pair of opposite sides and one pair, right? No, I'm sorry. Opposite sides are congruent and parallel, then the quadrilateral is a parallelogram. Yeah. So in this case, BC has to be congruent to AD, and BC has to be parallel to AD. When both of those things happen, then we can say that it's a parallelogram. Alright, so that's theorem 8 and 9. Again, this is unique in that it's not an inverse of the previous section. This is only one, and it's proving it parallelogram. Theorem 8.10, that is an inverse of the previous one. If the diagonals bisect each other, then the quadrilateral is a parallelogram. If we want to draw a picture, A, B, C, and D. There you go. Okay. Okay. Here they want to know how can you show that they're a parallelogram. If you look at number 2, they're both 30 and they're both parallel. Opposite sides, top and bottom, both 30. So for number 2, we can say it's a parallelogram because of theorem, what was it, 8.9? Theorem 8.9. So one pair is both congruent and parallel. For number 3, it's a parallelogram because opposite sides are congruent. Number 4, it's a parallelogram because opposite angles are congruent. For what value of x is it a parallelogram? So we just set those guys equal to each other. So 2x equals 10x minus, or 10 minus 3x at 3x. X equals 2. The math behind these guys is pretty straightforward. You're going to set a lot of things equal to each other and solve. Not too crazy. So some analysis of how to show guys parallel. Notice that parallelogram, the basic definition is that opposite sides are parallel. If you want to prove the parallelogram, opposite sides have to be congruent. Theorem 8.7, Theorem 8.8, opposite angles are congruent. Theorem 8.9, which is different because it's not the converse of the previous section. One pair of opposite sides are both parallel and congruent. And then if the diagonals bisect each other, then we can say, hey, you're a frickin' parallelogram. Alright, so this section does a little bit of coordinate geometry where we can utilize all those different ways to prove them parallel. So in this particular section, this example, they did a pair of parallel sides, opposite sides, and proved that they were congruent by using the distance formula. And they proved that they were parallel by getting their slope. That's one way. So they used Theorem 8.9. We can use any of these theorems. We can say, they ask you what other way you can do it. I'm not going to do the math, but we can say use the distance formula. This is one way to do it. Distance formula. And you can use that to prove that, what did I prove before? ASCD and AB. So we could prove that AB is equal to CD, and we can use it to prove that AD is equal to BC. And that would be using one theorem. Another one we can do is we can use slope formula. And say that AB is parallel to DC, and that AD, oh, that should be AD, is parallel to BC. That should be AD. Okay. We can also use the midpoint formula and you could use the midpoint formula to find the midpoint of AC and find the midpoint of BC. After you do that, you can prove that A to the midpoint, so I'll say AM, M equals midpoint, I can say that AM is equal to MC, and BM is equal to MD. I could also do that. And this one is probably the more rigorous one of the one to find, because you have to then, after you use the midpoint formula, use the distance formula here. To find those. To refresh your memory, because you might get a coordinate geometry one. Distance formula for some x1, y1, and xt, y2 is the absolute value x2 minus x1. Oh no, not absolute value. The square. Plus y2 minus y1 square root. That equals the distance. Midpoint, that guy is x1 plus x2 over 2, y1 plus y2 over 2. And then you guys better remember slope. Slope is y2, rise over run, y2 minus y1 over x2. Hello. Oh boy. x2 minus x1, if I could write it. Oh no. No, that was in the report. What happened? Oh, don't do that to me. Wow. That's never happened before. Over x2 over x1. Alright, so that's that section. And I guess in the nick of time, I hope you have a great rest of your day.